Hello everyone, Mr. Schleicher here with another chemistry lesson. This one's pretty short. If you run into any issues or have any questions, please email me at that email on that first slide, jason.schleicher@garlandisd.net. Um, our learning objectives for this lesson are pretty simple. We just want to describe properties of gases, and we want to identify when a gas is more ideal or it behaves less like an ideal gas. So first of all, what are our properties of gases? This is pretty simple. Now, as you recall, gases are made up of a bunch of little particles, just like any little bit of matter. And gases, all these particles have random motion, which means that these particles end up like spreading out and expanding to the volume of any container. Um, that also means that there's a lot of empty space between every single gas particle. If there's a lot of empty space, there's not a lot of mass there. So it's actually very low density. Gas is more, you can consider gas would float on a lot of other substances because it's less dense. That's why we have our oceans on the ground and our atmosphere in the sky. The other thing about gas is all this empty space in between every single gas particle means that gas is actually very compressible. What this means is that you can actually like squish these gas particles together pretty easily. And some examples I want you to think about are, containers of hairspray, things like that. You just pressurize gas, you put it into that can to get it really close together, and that was done fairly easily. Um, Another example are like car tires, for instance. Whenever you're riding in a car, as I'm sure many of you have done, there's a reason why we don't break our backs every time we're in the car. That is because those gas particles in the tire is part of the reason. Whenever you hit into a bump, they will compress a little bit and absorb some of that impact of the bump, and that makes it a much smoother ride. Okay, so an ideal gas versus a real gas. Remember with ideal gas, we basically talked about some assumptions where, hey, gas particles have zero volume, like an ideal gas volume, or an ideal gas particle. And a gas particle does not have an attraction with other gas particles. It turns out every single particle, every single molecule in day-to-day life, when you bring it close together, there's a little bit of an attraction there. And those attractions help do things like make sure my body doesn't fall apart or keep a piece of paper together, things like that. That's what holds most objects together. And it turns out gas particles have the same sort of attraction. But normally gas particles are pretty spread apart, so you're not going to see that attraction a lot. Um, However, it does happen. If a real gas particle comes close to each other, then it will attract a little bit. So we're going to talk about some conditions where that might happen. We want to talk about when do gases behave less like an ideal gas? When what we might notice that has volume, when would we might notice that a gas particle is having attraction with another gas particle? So first of all, when pressure is very high in a container, for example, think of like a pressurized gas canister, think of like maybe a tire um, of a car or a balloon. When pressure is really high, the volume of each gas particle becomes more noticeable because all the gas particles there's more gas particles in less space. So you actually notice the volume of those little particles more. The other condition here is when temperature is low. If your gas particles are very cold gas molecules, that means they are moving around more slowly. Remember, colder means less kinetic energy there. So if gas particles are moving more slowly, that means whenever they go past each other, they actually have more time to kind of show their attraction with each other. And you'll notice that chemically, and it will behave less like an ideal gas because it does show that attraction. So this is the part of the video where we're done with all the content. It was really short this time. So what I want you to do is try answering all these questions, and then I'm going to go over them and say how I would answer them. So pause now, try to answer. Okay, so question one, describe a gas particle. I'm thinking like a particle that has high kinetic energy, it has random motion, it's spread out. That's a gas particle to me. Um, Number two, Are there any bonds between particles in a gas? No, I mean, you might feel some attraction, but there are no bonds between the particles of a gas. Um, in a certain gas molecule, like for example, carbon dioxide or oxygen gas, you might see chemical bonds within that gas particle, but otherwise there are no bonds between different particles of gas. Number 3, how does increasing temperature affect the speed of movement of gas particles? It gets faster. Speed goes up, kinetic energy goes up. Number 4, gas is compressible. Give an example of when you can compress gas. Blowing up a balloon, for instance, filling up your car tire. Those are 2 pretty real life examples to me. 5, use one word to describe how the particles move in a gas. I'd say randomly, just all over the place. 6, real gases behave most like ideal gases under the conditions of high pressure or low pressure. Most like ideal gases with low pressure. And then high or low temperature. It's more like an ideal gas if temperature is high, because then the particles move around too fast to really interact with each other. Number 7, how do the particles of a gas move around? Randomly, bouncing around. Number 8, pressure is defined as what over what? Force over area, that is pressure. And then 9, name 3 gases in your life. Okay, I'm just thinking about what I'm breathing in right now. Nitrogen, oxygen, and I breathe out carbon dioxide. 3 gases right there. Number 10, temperature is the measurement of the average what energy of the gas particles? Average kinetic energy. And that's it. Let me know if you have any questions. Use my email at the start of the video. Thank you.